Okay, nice job yesterday. How can we graph a circle whose center is not the origin? Now today is our aim. So hopefully you did the do now before starting the video. To find the diameter, I'll first find the radius, which is the square root of the 121. So the radius is 11. Diameter is going to be 2 times that, so 22. The center again is 0, 0. That's all we covered yesterday. Area in terms of pi, knowing area equals pi r squared. So pi times the radius we found was 11 squared. So 121 pi is your area. Circumference is equal to 2 pi r, or pi times diameter. But the one on the reference sheet is this one, so that's what you've seen more often. So 2 pi times the radius, which is 11. So in terms of pi, it would be 22 pi. Okay, so now we're going to be moving away from the center being at the origin. And if you look at this link, it's really great. Oh, I definitely lost it. Sorry, guys. Okay, so play with this a little and watch. Right now, while the center's at the origin, you see the equation on the bottom left, x squared plus y squared equals 25. So we know what happens when you change the radius bigger, just the number that it's equal to is going to change. But now, looking at the blueprint equation of the circle, do you see the x minus h squared in the upper left corner of the grid plus y minus k squared equals r squared? So watch as I move the green slider, the h, to 1. Look what happened. Now inside the parentheses is an x minus 1, x minus 2. As we move the center horizontally, it changes that number. When I go right, it's minus that number. When I go left, it's plus that number because it's minus a negative. Okay, and then if I move the blue slider, it's going to affect the number in the parentheses with the y. So you guys could play with that so that you truly understand what those numbers in the equation mean. So right here, the example that we put down, when there's a minus 2 here and a positive 3 here, the coordinates of the center are positive 2, negative 3. So this is the opposite of the x coordinate, the opposite of the y coordinate, and the radius is still the square root of this. So here's 9. If you look from the center out to the circle, it's 3 units away. So here is your general equation of a circle. You have to realize that HK are the coordinates of the center, and because of the minus sign in the equation, you're going to have the opposite of those two numbers in your center. So here, when the equation is given to you in this example, the center would be the opposite of minus 5. 5 is the x coordinate. The opposite of the positive 7. Negative 7 is the y coordinate. And your radius is the square root of 169, which is 13. All right. Now they're giving you the center and the radius and asking you to write the equation. So I'm going to put x, opposite of the negative 4, plus 4 squared plus y. If the y coordinate's positive 6, I'm going to put minus 6 squared equals 12 is the radius, so I'll do 12 squared and get 144. Next example. Here they give the diameter instead of the radius. So opposite of 2, x minus 2, because you're doing minus the 2, plus y, since there's a minus 5, you do minus negative 5, so it's plus 5 squared equals, the radius is 7, so I'm going to take 7 squared and get 49. So that's going from the center to the equation. Write the equation of the circle whose center is negative 9. So x squared isn't going to have a number adding or subtracting because you have the 0, so I'm not going to put a parenthesis, plus the minus 9. So if I do y minus negative 9, it's y plus 9. It was the opposite of the coordinate, equals, here's the radius, we have to square it. So the square root of 20 squared is just 20. You can put that in the calculator, but anytime you take a square root and square it, it's just going to be the number under the radical. If there's a number in front of it, as I've showed you earlier this year, you should put it in the calculator. Okay, now graph it. Before I graph it, I get your center and the radius. The center, take the opposite of the two numbers in the parentheses, positive 1, positive 2, and the radius is the square root of the 9, which is 3. So I first plot the center at 1, 2, and then I'm going to take 4 points that are 3 units away from that. So 3 units to the right, 3 units up, 3 units to the left, and 3 units down, and then draw the best circle you can. And then label it with the equation, of course. So you need the center and the radius. Just like back when you learned how to graph linear equations, you needed the slope and the y-intercept with a circle. You need the center and the radius. Here's the opposite. They gave you the graph. So I'm going to get the center and the radius from the graph before writing the equation. So the center is negative 2, 4. That's the coordinates of that point. And now from that point, horizontally or up or to the left or down, I could get the radius. It doesn't matter which direction you go because it's always going to be the same, 4. So inside the parentheses, I'm going to put x with the opposite of minus 2, plus 2, squared, plus sign, y minus the 4, squared equals the radius squared, 16. Okay, so there were a couple of multiple choice questions like this. They want to know if a point is a solution to the graph, so you plug it in. I mean, you could also, if you put it in the calculator, you can't use a table of values because it's not a function, as I mentioned yesterday. So we could just plug the 1 in and the negative 6 in for x and y. So 1 minus 3 squared plus negative 6 plus 11 squared, does that equal 25? Negative 2 squared, you could use the calculator, but I'd rather just put it in, and I could already tell it's not equal because 4 plus 25, not equal to 25, so the answer is no, since the ordered pair does not satisfy the equation. You look, it said explain, so that's how I would explain. Okay, now this one is a little extra challenge. They didn't give us a graph, but I notice they give us the center. Now that part makes it easy to write the equation. But then it tells us 1 point it passes through. But notice, since the x coordinates aren't the same, or the y coordinates aren't the same, I know that these points aren't horizontally or vertical to each other, so I wouldn't be able to count the boxes to getting the radius like I would be if it was across or up and down. So first, to get the parenthesis part, I'll just set that up for us. I'm going to make sure I use the center, not the other point. Okay, so the 2 in the x spot, so it's x minus 2, negative 3 in the y spot, so it's y plus 3. Now, how can we get the radius? If we're going from 2, negative 3 to 6, 2, how could we get the length of that segment? If you remember the coordinate geometry topic we just passed, you could use the distance formula. If you prefer, you could scroll up and graph it and use Pythagorean theorem. I might do that afterwards because I think this is the last example. So first, let's just use the distance formula to practice that from the last topic. x2 minus x1 squared plus y2 minus y1 squared. So I'll take the two x values for the first parenthesis. I'll start with the 6 minus 2 squared. So that means I'm using this as my x2, y2, and this is my x1, y1. So 6 minus 2 squared plus, now I'll subtract the y coordinates, 2 minus negative 3. 2 minus negative 3 squared. So when I simplify that, you could just put it in the calculator. It's going to be 4 squared plus 5 squared. So the distance, that d is distance, not diameter. So don't get confused. 16 and 25 is 41 under the square root. So that is your radius, actually. If you go from the center to a point on the circle, that's your radius. So I'm going to put, since that's my radius, I'll do the square root of 41 squared and get that this is just going to be 41. All right, so 2 negative 3, 6, 2. 2 negative 3 and 6, 2. Right? If I wanted to get, so this is the center and a point on the circle, I could also draw the right triangle and get that I have a leg of 4 and a leg of 5. So this was the one like in that homework the other day that a lot of you treated like it was a 3, 4, 5 right triangle right away, but it's not, because the legs have to be 3 and 4 and the hypotenuse would be 5. So you would do 4 squared plus 5 squared equals c squared, which again is the 16 plus 21, which is 41 equals c squared, and you would get the square root of 41 as c. So you could use the distance formula and Pythagorean theorem interchangeably, and you would only need to use them when they're giving you a center and a point on the circle that's not horizontal or vertical from the center.